Okay, today we will cover two chapters, supplement 6 and 7. First, in the supplement chapter is statistical process control. Talk about variation first. When we cover quality part, then I exampled like if I produce 1-inch bar, then first one check the size, then 1.05, second one 1.03, and so on like that. So designed specification is like 1-inch. So variation is deviation from like a mean. And then two types of variation: assignable variation and common variation. Assignable variation, after test, like in the process, then if we find the cause of that variation, then later we can change or fix that, then the variation gone. So if we can handle that variation, that is assignable variation. The common variation, sometimes we don't know the cause of variation, but naturally happen that variation. So that is a common variation. So sometimes we cannot fix that variation. So there are two types of variation: assignable and common variation. The upper and lower specification limit, the same example, 1-inch, then 1.5, 1.3, 0.97, and so on. Then I asked which one is good, which one is not good. Then based on the manufacturing quality view, then if it conform a certain range inside, then we can say it is good. Outside, then it is not good, like that. So that range, upper and lower range, that is the upper and lower specification limit, upper limit and lower limit. And process control, monitor, when we say quality control, take a sample one by one and then test, then this is good, this is not good. So we can quality control one by one, but test the process itself, then take a sample, and then we can test. So monitor that process kind of output, then if it is good or not good, determine if it is good or not good. That is process control. And then statistical process control. Using a statistical method, determine if it is good or not good. So using kind of statistical method we will talk about. So testing a random sample of output from a process to determine whether the process is good or not good. Then quality characteristics, attribute and variables. Attribute, if we took statistics, then they in statistics, the variable like a numerical variable and categorical variable divided like that. Then attribute is a kind of categorical variable. You know, when we test light bulb, so light on, then it's on, then we determine that is good. On, but light doesn't up, then that is not good. So we can determine if it is good, it is not good. Pass, not pass. Something like that. That is an attribute. So in category, good category, not good category. Good quality, defect, like that. So test and quality using that attribute, categorical variable. And then variables in statistics, we call it numerical variable. By the way, this attribute kind of number, but by counting. So test 100, then among them, like how many are defects? So 1, 2, 3, 4, 5, no, we can count. Variables, weight, volume, size, and so on. To get this number variable, usually we use kind of tool to get weight using a scale. Volume, kind of something, what do you call it? Something, device. And then size, we need a ruler. So using something tool, measure size or something, then we can get number that is variables. So based on characteristic, quality characteristic, if it is an attribute or if it is a variable, then we use different method. If quality characteristic is an attribute, such as good or not good, then we can develop this P chart. Then we can determine if it is good or not good. P chart. P means kind of probability or percentage, something like that. So P bar, kind of average probability. So P bar equals total number of defects from all sample divided by number of samples times the sample size. If I take 100 sample, and then next time take 100 sample, and 10 times, not 10 times, 5 times, then number of sample is 5, and then sample size of each sample, that is 100. And then standard deviation of that probability equals square root of P bar, this one, times 1 minus P bar divided by N. And then using this formula to get upper limit and then lower limit. So P bar plus Z score. This one about what quality control limit use. Earlier, when we talk about quality, then 6 sigma quality control, 3 sigma quality control. So if they use 3 sigma, 3 standard deviation quality control, then Z score is 3, 6, and 6. And then this one standard deviation, lower limit, minus, and so on. But sometimes we cannot get standard deviation, but usually we can get. Okay, example. Each sample size is 300, and then take 10 times of sample. So the number of sample is 10, and sample size is 300. So 91 total defect divided by number of sample and then sample size. So P bar average percentage or probability of defect is 0.03033. Then standard deviation equals square root of P bar times 1 minus P. This one I mistype without this one, 0.03033 divided by 300. To get this standard deviation, we use sample size n, then square root. So standard deviation is 0.0099. And then 99.7 confidence, then Z value is 3, like a 3 sigma quality control. This one, confidence level, where is the pen? Confidence level looks like this. On normal distribution, 99.7, that means from mean, distance from mean is a plus minus 3 sigma. Then inside area is 99.7. Okay, so use 99.7 confidence. Then Z value equals 3. So P bar plus 3 Z score or Z value times standard deviation. Then upper limit is 0.06004. And then lower limit minus, and then 0.0063. So using this upper limit and lower limit, then we can draw chart like this. Upper limit 0.06004, lower limit 0.00063, and then these dots from this. Because we use P bar, and then each one probability of defect in first sample, second sample, and so on. So P, the probability of each sample, P1 equals 10 defect divided by sample size. And then next one, that is 0.03. And then, is it right? 0.333. And then next one, this one is less than that one. And then next one, P2 equals 8 divided by 300 and so on. So after get probability of each sample of the defect, then we can defect those probability of each sample. So this process, all samples are in between upper and lower control limit. So we can say this process is working fine because all the sample probability of defect is inside. Okay, question? So we can use formula, calculate upper and lower, and then we can defect like this. I will show you using Excel how to develop this P chart. So open this file. This file is on Moodle, the example file. So if you can download this file and then work together. You know, most of you use only one screen display. Then if you up this one, then maybe you cannot see my lecture. So when I teach in undergraduate course, then students said, "Oh, I cannot do that because I have only one screen." So I said, "You can divide." So you can divide your screen half and half, and then other like in the so one side you can watch the lecture, and then the other side using Excel like this. Okay, are you ready?
Yep.
Mm-hmm. Okay, I brought whatever the formula we need here. So first we need P bar. So P bar is total number of defects from all sample divided by number of sample times the sample size. So we need total sample and then total defects. So type this cell. Oops, I need keyboard. So type equal, then sum of. You can use this function or just type sum of, then you can see, then double click that function. And then specify the range and then enter and 3000. Okay, I will make it bigger to see better. Better, right? And then we need a total number of defect. So we already use sum here. So just copy. So 91. So P bar is total number of defects, 91, divided by number of sample, 300 times number of sample is 10, and the sample size is 300. So 10 times 300 is this one, 3000. So that will be, P bar will be equals number of defect, 91, divided by total sample So 0.030333. The same as we did using a formula hand calculation. And then standard deviation. Anytime you need time, then ask me, like hold on right there. Okay. So work together. And then standard deviation, square root of p bar times 1 minus p bar divided by n. So by the way, n is 10 because 1, 2, 3, 4, 5, 10. N is not 10. Sample size is 10, so 300. Sample size n is 10, not 10, 300. So this one equals square root. So function is sq rt. So square root. Then p times. We need to know one more. So p bar, this one, times, and then open parenthesis, this is again, and then 1 minus p bar, then close. So this closing parenthesis, close this one, and then we need to close one more, and then divide by n, 300. You can type 300 or just click this one and then close it again. Then looks okay, looks right. Then enter. Then 0.0099. I think it's right. The upper limit and lower limit. Upper limit here equals p bar plus z score is given z score is 3 times standard deviation, this one. So click this one and then close and enter. So upper limit is 0.06 and the lower limit is minus. But the same calculation, p bar, oops, equal sign first, equal p bar times plus. Did I use plus there? Minus because it's lower limit, minus, and then z score is 3 times standard deviation, enter. Let me check. Yeah, this is right. Okay. For that chart, we need upper limit, lower limit, and then p. And then one more, I will depict that average. So we need upper limit, we need lower limit, we need p bar, and then we need p. So upper limit, that one equals, we already got here. So type that one, click that one, and then all the way down, we will use the same one. So make it absolute by type F4 function key, enter, and then copy all the way down up to this point, we need a 10. And then lower control limit equals the same. Click lower control limit and then F4 function. Make it absolute and then enter. Then copy all the way down using dragging down or move cursor right lower corner and then double click. And then P bar, this one, so equals this one, and then make it absolute, enter, and then double click all the way down, and then P, we need a P. P is probably of a defect for each sample. So this one equals defect divided by number of inspect, enter. This one for each one, so we don't need to make it absolute, just let it change. So this one, let me change decimal point. Yes. Okay. Then draw chart. Are you with me up to this point?
Yes.
Okay.
Yep.
Now, using Excel, we can draw chart. So specify the range. And then go to insert, then chart. So you can click recommended chart, then Excel recommend available chart like this, but control chart looks like this. So I will use this one and then OK. Go. And then click this one, and then we can change title. P chart. It's fun, right?
Dr. Kim, which was the chart that you selected from the recommended ones?
Yes. But charts.
Yeah. Which
So
one did you select?
Go back and then because this chart is a line chart, so you can use recommended or just directly a line chart, something like this. Or if you click this recommended, then this one.
Okay, thank you.
Okay, good. It's fun, but you need some tedious job. I will show you the fastest and then easiest way to develop this P chart. Okay, you know, I like using the megastat. Oops. Oh. Did I give you a megastat? No. Just a moment. I need file. I will bring up the file because I don't have that megastat here. But for this class, did I give you a megastat? No.
No.
Okay, I will upload that one. Just a moment. Where it is? You know, at the beginning of this today class, I said my computer problems. Last Sunday, when I do something with my computer, then suddenly it was gone. So I tried to figure out what's the problem. Then I think the power supply unit malfunction. So, but I cannot sure if it is. So if I bring that computer to a technician, then I think at least $200 to fix that one. So, but this time, you know, affordable computer that CPU tower only between $300 and $400 I can buy. So I decided to buy another one. So I ordered, and then today I received a moment ago. So I didn't have time to set up that one. So now I'm using this my laptop. So and my laptop doesn't have that program. Okay, just a moment. It's easy way, but we need a certain Excel add-in. That is this one. So I will upload this one on Moodle. Come on, which one? So you. So this laptop is a bit slow. Okay. In there. Sorry, it takes some time. Load. Now it's working. It's slow. Network or computer, whichever, slow now. Oh, yeah. Okay, I uploaded that Megastat on Moodle under the supplement 6 and 7 directory. So you can find the Megastat. I will show this screen. So in this supplement 6 and 7, you can see this Megastat. So download that one somewhere. It is an easiest way, but it takes long. So download this one, and then don't open that file. Don't open that file, just download. Then go back to Excel. Okay. Did you download? So are you ready?
Yeah.
So that Megastat is add-ins, one of add-ins. So click File, and then go to Options. Then open this one. Because now Megastat is add-ins, so click this one, and then change, and click Go. Then I need a Megastat, but there is no. So click Browse. And then find that file wherever you download it. And I have this one here. So click this Megastat, and then OK. Yes. So Megastat is ready with the checked. Then click OK. Then you can see Megastat under this data menu here. This one is similar to, I don't know if you used, if you have experience now with that SPSS and SAS and so on. So this one is similar, but it's kind of free. So Megastat, click this one. Are you ready? Do you have Megastat now? Okay, click this one. Then this window open. And then find this one, quality control process chart. Click this. Then this one ask input range. Okay, input range is number of defect. So specify I cannot make this one big. So do it again. Input range. It doesn't matter include a label or not. Input range. And then we are going to develop P chart. So second radio button, P, proportion non-conforming. So click this second one, and then sample size 300. Then click OK. So without calculation, if we use a megastat, then by a couple of clicking, done. You have assignment. So when you do an assignment, either way, using Excel or megastat, either way, okay. Question? Okay, good.
Sir, you took sample size as a 300. That means
Yes.
the second column. Show me. Can you please show me the example one? So the
Sample
number of
size.
inspector in all the 10 samples as a 300. That's why we take sample size as a 300.
Mm-hmm.
Okay.
In case if sample size is different for each sample, then what happened? We cannot use that megastat. Instead, use other add-in. But use the if you need that other add-in, then I can give you. But this time, the same sample size. Okay. So for a megastat, sample size is 300 now. Okay. Okay. And next one. Make sure. Okay. Next one. Process control with variable numbers using a tool that measure. So it's like an the size, something like that. Then we use X bar and R chart for this quality control or process control. UCL X bar equals double X bar. That means X bar is the mean of X, and then double X bar means mean mean of average plus z-score and then standard deviation. So from a sample, we can get standard deviation and then z-score, the same as earlier one. If we use 99.7%, then use z equals 3. And then 87, 67, then g equals 2, 1, or 6, and so on. If we can get a standard deviation, then use this. Or if we cannot get a standard deviation, then many cases we use chart. So we can use a formula like this when we have a standard deviation. If we cannot get a standard deviation, then we use this formula. So UCL x bar equals x double bar plus A2 from the chart. When sample size, take sample 1, 1, 2, 3, 4, 5. Sample size is 5. Then we use the chart, sample size 5, and then A2 is 0.58. D3 is 0, and D4 is 2.11. Like this. So R X bar test. Maybe this one designate size is 10. Then take one sample and then measure 10.6. Next one 10.4. Next one 10.3, and so on. So sample 1 is 5. Sample size is 5, and then average of this sample is add all divided by 5, 10.28. And then R means range. This range in this sample, biggest one, 0.6 minus smallest one. So 10.6 minus 9.9 is 0.7. And the next one, largest one, biggest one is the 10.33 minus smallest 9.97. That is the range. So after get range or X bar, double X bar, and then mean of range, then plug in. Then we can get upper limit, lower limit, upper limit, lower limit for X bar, and then R. Then we can draw. Then or the measurement of a sample mean inside between upper and lower limit, and then a range. Because the range is always positive, so a lower limit sometimes many cases 0. From 0 to upper limit, or range kind of deviation in all deviation in upper limit and lower limit. So we can say all the points are well within the control limits. The process is on normal behavior. Okay. Now 6:50, so take 10-minute break and then continue 52. So I will be back at 7 and then continue with the Excel. Okay, see you. Okay, I'm back. 1 minute early. Okay, I need numbers. Okay, Excel again, and then example 2. Looks like this. The same one, same data. So we need X bar, make it bigger. So X bar, the same, equals average. So you can find the average from this function or type average here. Then specify range, enter, and then down up to there. And then we need R. This one, use some function, range, biggest one minus smallest one. So using Excel function max and min. So equals max, max, double click. And then this one, ask range. So max among those. And then close. So range is maximum minus minimum. So minus mean. And then same range. Enter. Oops, I should close. Okay. Wow. And then copy all the way down. Oh, too many decimal point. Change. Maybe 2 decimal point. Okay.
Sorry, sir. Can
We
you repeat
need,
for the X bar?
say again,
Can you repeat for the X bar?
X bar.
Yeah, sorry.
Okay, no problem. Equal, X bar means the mean of the sample. Excel function is average, so type average. And double click this one. And then specify that range up to this point, F. And then close and enter. And then you can copy all the way down. Got it?
Yes, thank you.
Mhm.
And Dr. Kim, what function did you use for R?
Max and mean.
Okay. Thank you.
Max this range
minus
and
min.
mean this range, and then copy all the way down. Then because they are not absolute, so if you move, then the cell number change. Okay.
Yeah, thank you.
Then we need double X bar, this one, and then we need R bar. So double X bar equals average of, or so average, type average, and then range, and this one the same, so just a copy. Good. And then UCL, upper control limit, this one. So upper control limit X bar equals double X bar. So equals double X bar, this one, plus A2 from the chart. A2 is 0.58. Because I will use multiplication, so open parenthesis, and then A2 is 0.58 times R bar. This one is R bar, and then close, enter. So upper control limit for X bar is 10.5533. And then lower control limit, I didn't copy it, but then minus. So equals X double bar plus minus, and then that one is A2, the same. So A2 is it right? Yeah, the same A2. So 0.58 again. Times R bar, close and enter. 9.86. The R, UCL for R, D4, D3. So D4, 2.11. So 2 point, oops, equal sign first. 2.11 times R bar, enter. And D3 is 0, so equals 0 times whatever equals 0. Okay, now we need data for a chart. Upper limit X bar equals this one, and then make it absolute, enter, and then copy all the way down to here, and then LCL equals this one, make it absolute, enter, oops, And then average x double bar, so equals this one, absolute, enter. Okay. And then x bar, this one, so just copy. You can use right click and then copy, or Control C, then right click and then only number. Right click and only number. If you just use like a Control V, then it's different. So use right click, oops, do it again. X bar, Control C, and then right click, and then only number 1, 2, 3. Then just copy now. We don't need this cell. And then UCLR, this one equals UCLR absolute, enter, and then copy all the way down. LCLR, that is 0. So you can click this one or just type 0. And then copy all the way down. And R bar equals this one, R bar. Make it absolute. Enter. And then R. Copy. Control C. Right click. And only number. Done. Too fast? Okay, now we can draw the same, specify range, and then insert and recommend chart. Then find, oops, here, line chart. Okay. This one is X bar chart, X. Move this one. No. See, do it again. Ah. Okay. Then R chart. Line chart again. This one is R chart. So as you can see, all numbers inside the range and the measurement, the variables inside. So we can say this process is working normal, or this process working good. Question? And then again, we can use megastat quality control process chart. Input range. We will develop X bar and R chart. Input range. All data. You may include title, not sample number, only data. And then variable X bar and R chart. Very simple. Click OK. Without calculation. Upper limit, lower limit, X bar for range. This is X double bar and this one is R bar. This one is X bar chart and this one is an R chart. Very simple and then fast.
And also fun.
Yeah. Okay. I think you can do it. And next one. Another chart. Earlier, P chart. C chart is similar to P chart. When we develop P chart using the number of defect or the number of something happen, and then with sample size. C chart is similar, but there is no sample size. Just the time span or the period. Used to control the number of defect or something happen per unit of output. Then using this formula, C bar plus minus 3, this one also Z score, and square root of C bar. C bar is the number of total defect divided by the number of sample. For P chart, we need the sample size, but without sample size, just the number of sample, then we can develop this C-bar chart. So example, Red Top Cap company received several complaints per day. So first day, second day, third day, they are sample. So during 9 days, so sample size is 9, the number of sample is 9. Then each day complaint, the number of complaint is 3, 0, 8, 9, 6, and so on. So they are kind of the number of defect or the number of happening. So C, actually that is C bar. C bar, that is mean of the complaint. So C bar equals total complaint. So 3 plus 0 plus all the way divided by the number of sample, 9 equals 6. So on average, 6 complaints per day. And then upper limit, 6 plus square root of 3 times 2.4. I omit 3 here. So it looks like this. So using Excel, example 3. So we need C bar. C bar is the number of total defect. So that is just equals sum of or enter upper limit, lower limit, C bar equals C bar plus square root of C bar, enter, and then minus, so equals C bar minus square root of C bar 54. C bar is not 54. Later, C bar. I will change this one. C bar is divided by the number of samples. So divided by 9, that is 6. So change. So C bar is sum of all divided by the number of sample, 9. So 6. Then upper C bar plus square root of C bar. And then LCL, C bar minus square root of C bar. But lower limit of C bar, C chart, always 0. Always 0. So LCL for C should be 0. looks like this. So change 0, and then the same process. C bar equals this one absolute, enter, copy all the way down, upper limit equals this one absolute, enter, copy all the way down, equals lower limit is this one 0. Just make it absolute, or just type 0. And C is they are C, so copy. It doesn't matter because it doesn't have the function there, so just Control B, okay. And then again, we can draw. C chart.
So can you calculate UCL again?
C?
UCLC, yeah.
You, I don't understand.
Can you calculate upper limit and lower limit again?
Yeah. Okay, Okay. Upper limit, C bar plus 3 times
But
square root of,
sir, you didn't include 3 in upper limit and lower limit. That's why I'm confused.
yeah. I heard it. Thank you for a correction. And this one, 3 times 10, change it, 0. Yeah, good. Thanks for a correction. Because there is no negative complaint, so lower limit is 0. And then now we can use megastat again, simple way. So quality control process chart. Then input range is number of complaints. And then the last one, number of defects, C, and OK. Very simple. So automatically this one calculate upper limit, lower limit, and C bar, and then draw. So based on this one, we can determine like this all complaint all day of complaints. in low. Something like that. So when you do the assignment after develop the charts, whatever designate chart, proper chart for that data, then comment, include comment about that result, okay? You know, if one day complain out of range, then you can say except fourth day or others are in normal range, like that. Or other example, then if 17th sample out of range, then and or others in normal, then you can say except 17 sample or others in control. So I'm not sure in the future if you need this kind of control chart for your work, then maybe then you can draw. You know, if you use megastat, then the chart is very simple. But if you use Excel, then you can use color, and then later you can change color or shape. Then you can change shape, and then you can change color inside. It's slow. Come on. Yeah. So you can make a better chart, look better. Then if you click this one, right click, then where is that move chart? Wherever, come on. My computer is slow. I did. Use this move chart. Then you may new sys, then it produce new chart on a new sys. So then you can make it bigger like this or separate. Okay. That's all for chapter supplement 6. And the next one, I will bring up okay, next chapter. Not chapter 7. I need supplement 7. Wrong one. I uploaded the wrong one. Because my computer was problem, so I made a mistake. Many. Okay, I need okay, I will use about 30 minutes more. Just a moment. I will upload that file. Where is that file? I will find. Just a moment. 3-minute break. Where are you? Okay, then I need to upload this one. Too quiet, right? Okay, I changed that file on Moodle, and this one. Break-even analysis. Break-even analysis, using this, we can find break-even point. Break-even point is start making profit. If start a business or something, then if there is no fixed cost, then sell a certain volume, then this point, total cost line and then revenue line cross, this point is break-even point. So after this point, profit. Before this point, such So total cost equals fixed cost plus variable cost times Q. So variable cost and then price minus variable cost. That is, we call that margin. So this is margin, and then this is margin too. But from this point, this side is margin, but contribution margin. Contribution margin. That means contribute to offset fixed cost. So this margin offset or fixed costs on this point. And then after this point, this price minus variable cost is profit. So finding this point, so why that point is important? If a company produce something with this fixed cost, this company should sell more than this amount, volume. So finding this volume is important. A break-even point equals total fixed cost divided by unit price, price minus variable cost. Example, if there are 3 options, then first option, just buy and sell, like a retail store. Buy at $200 and sell at $300. No fixed cost because just buy and sell. Then produce using semi-automatic lathe. Then fixed cost, machine cost is 80,000. And then variable cost is 75. Using machine center, better machine, so higher machine cost, 200,000 and then $15 variable cost. Then if we draw those, before we draw, we need a total cost for each option. So total cost for buy and sell, let's say B, then no fixed cost, just 200 Q. Then second one, total cost, let's say lathe equals 80,000 plus 75 Q. And then last one, total cost machine center equals 200,000 plus 15 Q. So using those total cost equation, draw. Then the first option, buy at $200, no fixed cost. So start point from 0, increase by 200. Then second one, using lathe, 80,000 starting point, and then increase by 75. And then the last one, motion center, 200,000 fixed cost, and then increase by 15. Then there are some crossing point, 1, 2, AB. Okay, delete. So first point, use black color. First point here, on this point, the first option, second option, and revenue 300 cross. This is break-even point for using lathe. So we can get this one, break-even point for using lathe equals total fixed cost is 80,000 divided by price, that is 300, and minus variable cost is 75. So that is 80,000 divided by 225. Could anybody calculate this one? I cannot use the calculator now.
355.5.
350.
5.5.
5.5 approximately. Okay, 355. So approximately 356, right? So break-even point is here. And then next point, point 2, on this point, the third option and revenue cross, so break-even point for using motion center, that is in number. You can calculate that one as break-even point for motion center equals total fixed cost is 200,000 divided by price is 300 minus 15. So that is 200,000 divided by 285. I remember 701.
Yep.
So 701 is here. So that means if this company choose third option, then this company should sell more than 701 to make a profit. Okay, then next point. Point A, on this point, second option and third option cross. That means using lathe option and using a machine option, the cost is the same. And then point B, second option cross first option. first option cost and second option cost the same. So by number, on point A, total cost, the third option, motion center, equals total cost, the second option, lathe. So total cost, third option is 200,000 plus 15Q. And then second option, 80,000 plus 75Q. So simplify about Q minus 15 each side. And then minus 80,000 each side. And remaining is 120,000 equals 60Q. So divided by 60. So Q equals 2,000. So this point is on 2,000. Use like this. And then on this point, first option equals second option. So on this point, total cost, second option is lathe, first option is buy and sell. So second option is 80,000 plus 75Q equals first option is 200Q. So minus 75, then 125Q equals 80,000 divided by 125. Then I don't remember, maybe 540, 560. Can you get number? 80,000 divided by 125. 540?
640.
640.
Yeah.
Thank you. So this point is on 640. Okay. 2,000 and 640. What does it mean? What they change color. In this range, if Q is less than this point, 640, then there are three options, this one, this one, this one. Among three options, this one is lowest. So if forecasting demand is less than 640, then this company should choose this one, first one, buy and sell. If forecasting demand is between, Q is between 640 and 2,000, among three, this one, this one, this one, this option is the lowest cost option. So if forecasting demand is between, then second option is the best option. So using lathe option is the best. And then more than Q is more than 2000, then this one, third option is the lowest cost. So find the kind of the boundary, then based on forecasting demand, company can choose optimal or proper option. Okay. Okay. And next one is if a company produce or sell multiple products, then how can we find break-even point? So multi-product break-even point or break analysis, even analysis. Tonight, I used more time than I expected. So stop here, and then next Wednesday, continue from this point. However, my intended assignment was 2, but I didn't cover it for this one, so I will keep this one for next class. So you have one assignment from supplement 6. This one is about the control chart. So develop control chart using whatever. It's up to you, using a formula and then hand draw or Excel or using a Megastat. But then after develop that chart, comment from the result, okay? Within or something happen based on your chart, comment like one sentence, okay? Okay, because of my computer problem, so I made some mistake and then slow and so on. So anyway, thanks for coming tonight and then being patient, and good night.
Okay, thank you.
Thank you.
Thank you.
Thank you. Good
Thank
night.
you.
Thank
night,
you.
Doctor.
Good
Good night.
Good night, Dr. Kim.
Good night.
Dr. Kim, I have one question.
Okay, just a
For
moment. Let me
stop recording.
stop the record.
Mhm.